Hey guys, a little bit of an update. My software for screen recording went bad, so I needed to get a new one, which only limits me to 10 minutes per video, so I might be releasing videos in a couple parts. Because you guys know I love to take a long time on them. Anyways, today what we're going to be doing is making a hash cracker. Now, I know originally we were going to be making an email cracking an email brute forcing program, but I decided to split off with this to go more in depth on the brute forcing aspect of it. Now, starting off with brute forcing, for those of you that didn't make it to the meeting last time, brute forcing is just going and trying every single password combination of characters as a password to try to figure it out. There are other ones called dictionary attacks, which are basically more accurate, but they sacrifice time for a lot of memory, terabytes of memory sometimes. Anyways, going back to what I was talking about, brute forcing, we're going to be trying a lot of different combinations. But today, for an example, what we're going to be doing is hashing, or specifically hash cracking. And if you guys didn't watch my video before on cryptography, never mind, actually I didn't explain hashing in there either. So what is hashing? Hashing is basically a one-way function. When you plug in an input, it returns a unique output that you can't go back. You can't reverse engineer a hash function like a normal function. Once you plug in an input, it comes out with one unique output that is only that output. With other functions, like for example, y equals 2x, you could just divide y and you'll figure out what x was. Hashing functions, it doesn't work that way. So Python makes this really simple. It just has a built-in method that you can call, which is hash whatever. So let's hash ASDF. That returns a unique value, and there's no way of going back and reverse engineering to figure out what the original output. Now, what websites and different places will do is they will actually not, instead of storing your password, which says ASDF, they will store the hash value of it, and that way, if there is a breach or they're hacked somehow, the criminal can't do a lot with it. If they have the hash key, what they can do is they can brute force every value to try to come out to this hash key and figure out what it was, but that takes a long time. Say it takes an hour per password just to figure out the password for each of them. And if you have 1,000,000 of those, you do the math. That's a lot. So what they'll actually do is they'll just take that hash key, combine it with the username or whatever it is, and then they'll sell it for $5 $20 a piece, whatever. I don't know. I'm not a criminal, so I don't know what the go rate of these are. But they'll sell it, and then the individual buyer will go in and they will crack the hash key themselves. Taking 2 or 3 hours to do it, but at a price of $20 or whatever, they could be coming out to $500 return value. So it works out for all the criminals involved. So what we're going to be doing is a hash cracker ourselves, and just showing you guys again that whatever you plug in is unique, and it has a unique hash value. Now, moving on. What we're going to be doing is a brute force attack on it. So first we need to come up with a brute forcing tool. Now let's start off simple. We're just going to have a for loop. Sorry, Java has me confused. For I in range, let's say 0 through 10. Print it out I. So running that, and it just runs through all the different numbers. Pretty simple. But we don't want numbers, we want numbers, special characters, capital and lowercase letters, all the works. So here, actually, I'm gonna change this up a bit, and I'll explain why in a sec. Okay, 0 through 255. It goes through, fun, keeps going, whatever. Anyways, what we can do is, since we want those letters, numbers, special characters, etc., there's a couple ways we could actually do this and implement it. We could have an array that contains all the special characters, period, and reference each element of them, but that's big and tedious, and I don't want to type that much. I'm lazy. You know, one great man from Rainbow Six Siege said that laziness is, or efficiency is just clever laziness. But so what we'll be doing is we'll be using the CHR function, and I know you guys are familiar with it because you all obviously watched my cryptography video. Anyways, going back to it, CHR. And for those of you terrible people that didn't watch my cryptography video, I'm kidding. CHR is basically a function that will take a number value, a decimal value, and then return the character value of it. So going to an ASCII table, if I were to run the method CHR and pass it 16 or 48, it would return 0, or 49, it would return 1, etc. So when we do 0 through 255, it's returning all these different values from null to however on. This is a default table. So let's run that. Ooh, we're running low on time. Okay, so it goes. But we don't want all of this. This is a lot of gunk that we don't need. It's not going to be using these characters or null or delete or whatever. So let's limit it. Going back to this ASCII table, all we're going to be using is 33 through 122 because this contains numbers, capital, lowercase letters, everything that we could need. And it has all of the special characters that would be accepted. So it's perfect, 33 through 122. So let's modify this. And when it comes to brute forcing, cutting time is key, because from 0 to 255, cutting it down to 32 through 122, that could be saving us hundreds of hours of time. Literally, this does take a lot of time in processing. So running that takes much less time, and it's returning only characters that, yep, see, that was instant. And before, we never even got to the end. So that makes a big difference. Now we need to have, we're running low on time. All right, I'm going to wrap up this video and then continue it in another part. We're going to try to finish up, I'll try to finish up the whole brute forcing method. Then maybe we can do the actual hashing comparison, which shouldn't take long. Anyways, I'll see you guys in the next video.